Hi there. Welcome to Xamarin University. My name is Mark Smith, and this is IOS215, Editing Table Views. Before we begin, make sure that you download the class materials from university.xamarin.com so that you can go through the exercises. We've got 3 objectives to cover. First, we're going to look at some built-in basic editing features that you can enable on the table view in iOS to let users add and remove data interactively. Then we're going to look at some more recent additions to the table view that allow for quick operations to be exposed to the user. And then finally, we're going to look at adding some search support into a table view through a search bar. Let's get started by looking at some of the built-in editing operations that we can take advantage of when using a table view. We're going to look at the built-in capabilities of the table view that let a user add, remove, and reorder rows through the UI itself. The UI is completely supplied by the table view, and all we have to do is enable it and then respond to specific notifications. Let's start with a little bit of a reminder from IOS215. Remember that the table view has 2 objects which together supply the data and the behavior. The data source provides the data, and it provides methods to interrogate the data, and the associate delegate receives notifications about interactivity such as selection, highlighting, and when you tap things like the accessory buttons. You associate the data source through a UI TableView data source object, and the delegate through a UI TableView delegate object. You supply these by deriving from those 2 classes, creating an implementation, and then setting some properties on the table view itself. More commonly, we combine these 2 together using a UI TableView source, or if you're presenting a full screen table view, you can use a UI TableView controller. We went through all of that in IOS210, so if you're not familiar with that, go ahead and stop now and go back and view that video just to refresh your memory. The delegate notifications are exposed through virtual methods that you can override on any of these classes. Because this is a notification system, you generally don't need to call the base implementation. In fact, in many cases, calling the base class will throw an exception on any delegate type. You saw how to handle the selection notification and how to show details for a row by overriding the rowSelected method and then using a segue. So let's dive in how to edit our data live in the table view by overriding some other methods that are on the table view delegate. The table view has a complete API to edit the data that it presents. And you could program a set of custom UI gestures and widgets around the table view to use these methods to add and remove rows. However, Apple is very deliberate about the user experience that they desire. And so the table view has these underlying APIs, but also includes an interactive editing experience built into the table view UI, which allows the user to add, delete, and reorder rows directly. When this UI is activated, the table view calls methods on the associated delegate and data source to determine what features should be presented. The application can decide on a row-by-row basis what operations are available. In the application you see here, you can see that we can insert a row at the top, indicated by the green plus icon. We can delete the banana, peach, and asparagus items, indicated by the red minus icon, and the water lily is actively being deleted, shown here with the delete button. All of this UI is built into the table view and provided by simply turning on a built-in edit mode and overriding a few delegate methods to control the behavior. Let's look at the steps that are required to implement this feature. First, to enable interactive editing, you have to provide some way to activate it. This is commonly done with an edit button that's placed on the left or right side of the navigation bar. In this code, you can see that we're placing it on the right, which seems to be the most common approach. You can either create your own UI bar button item, or you can use a built-in definition supplied on the UI view controller class and exposed through the property edit button item. The advantage to using the predefined button is that it is localized automatically, and it automatically activates and deactivates the edit mode of the table view. If you use your own button, you will need to provide the text localization and the behavior yourself. The edit button will turn the editing mode on and off by calling the set editing method on the active UI view controller that the navigation bar is associated with. If you use your own button or some other UI paradigm, then you will need to call this same method to control the editing mode activation. It takes two parameters, both Booleans. The first indicates whether edit mode is on or off, and the second indicates whether the transition behavior between these two modes should be animated or not. This method will locate any child table view owned by the view controller and call a setEditing method on the table view itself to activate edit mode. This will in turn call setEditing on each visible UI table view cell to either turn editing mode on or off visually. Each of these setEditing methods are actually virtual, which means they can be overridden and used to monitor or even alter the transition in and out of the interactive editing mode. For example, you could stop a table view from entering edit mode if your application is in some state where it shouldn't be enabled by intercepting this method and not passing it along to the base class. If all you want to do is check the state of the table view, it also has an editing property which reflects the current editing state. You can also change this property value to flip the table view in and out of editing mode, but it won't perform the animation when you use this approach. Because it avoids the animation, it's generally not common to use this property directly, because it simply forces a re-render of the cell editing style. However, you can use this property if you know that the cell style has changed for some reason. For example, if you have an insert cell at the end of the table view, and you edit it and then you want to display a delete icon, you can change this property to false and then back to true to force the cell to re-render with the new editing state. When the table view is asked to transition to editing mode, it will first determine which cells in the table view can be edited in order to turn on the visualizations. This is done by calling the canEditRow method on the data source for each visible row in the table. The method must return a Boolean, true if the user can edit the row, or false if the row is not editable. The default is to return false, so you must override this method to enable editing support. Notice that it's passed a table view and an index path. That gives you some hint that this method is called multiple times, once per visible row, in order to interrogate that specific row and determine whether or not edit mode is available for that row. Next, you can override the editing style for row method on the TableViews delegate to control which operation is allowed for a given editable row. This also is called for each row that supports editing, and it returns a single enumeration value. The value you return indicates the icon that will be shown next to the row. You can return none for no icon, insert for the green plus icon, and delete for the red minus icon. Notice that these are mutually exclusive. You cannot have a row support both delete and insert, for example. It's one or the other. If you don't override this method, then delete is assumed. However, as with most of the delegate methods, the base class does not have an implementation since this is really a protocol, so don't try to call the base class. Let's try this out by adding the interactive editing support for an existing application that has a table view. So here we are in the Start Here HTML that comes with your lab materials. And of course, here you can get the slides and you can see the objectives that we've covered and that we will cover. And then we have the list of exercises. We're starting here on exercise 1, support editing operations in the table view. And if you click the exercises link, it will take you to the actual HTML lab that we're going to work through. Now, there is a starter application in the Part 01 resources folder that you'll need to open. Make sure to copy that off so that you can maintain a clean copy of your lab if you'd like to do it again, or save off the zip file that you downloaded from the university website. Once you open the application up, you'll see that it's a very simple table view driven application that lists a set of expenses. And our goal will be to add in some editing operations into the application. So the first thing that you're going to do is add an edit button to the UI through the pre-supplied button that's available off the UI table view controller. Remember, this actually comes from the UI view controller base class, but you'll add this button into the user interface into the navigation bar, and it will be placed here on the right hand side. And then you'll override the editing style for row method on the UI table view controller that will allow you to control the editing style that's presented. Here we're just going to say delete for everything, which happens to be the default, but it'll give you an idea of how you would actually do this if you were wanting to implement an insert or maybe perhaps set some of the rows to be none. When you run the application and you click the edit button, it will move into edit mode, and you should actually see the little delete bubbles show up on the left-hand side of each one of the rows. When you tap one of those bubbles, you'll be presented with the delete button that you would then be able to press. Now, at the completion of this lab, we won't actually have the delete support in the app yet, and so the UI will be presented, but you won't actually be able to delete any rows. We're going to do that next. So go ahead and pause the video at this point and run through the lab exercises and get this UI and go ahead and try it out and make sure that you can actually get into edit mode. And then when you come back, we'll go through the lab exercise together. So here I am in the starter project. If I run this application, you can see it is just an expense application that has a preset list of expenses that have already been built into the application. So here we've got some flights, a taxi from the airport, taxi to dinner, etc. Right now there is no editing operations available, so you don't see any button here. I don't have any gestures or anything. However, I can tap to select an expense and then edit the expense and save it back to my local database. Our goal is to add in editing operations, and the first step in that is always to add in some way to turn on the edit operations themselves. Now we're going to do that by going into the expense list view controller source file. That was that main screen that you just saw. And we're going to go and edit the viewDidLoad method. This is typically where we'll set up our UI and add any buttons into the toolbar and things like that. And so what we really want to do here is go ahead and add a new button into our navigation bar. And so I'm going to say this navigation item dot right button bar item is equal to this edit button item. So remember, this edit button item property here comes off of our base UI view controller class, and it presents a localized edit button, and we're going to go ahead and place it on the right hand side of the nav bar. There's also a left bar button item, and then there's also right bar button items, which is plural, and left bar button items, which is plural, that lets you actually set an array of buttons. If I run this application right now, you'll be able to see that the edit button will then be placed into the right hand side of the UI. So now I have an edit button, and when I click it, you can even see that we get all of our delete operations, and I can tap on one and I get my delete button, although it's not active at this point. Now, the reason why I do have an automatic edit mode is because the default state or the editing style for those rows is delete. But you can control that. And the way that we do that is we're going to override the editing style for row method. And what we're going to return here is the actual editing style we want to use. And so, for example, we could say cell editing style dot insert, in which case each one of those rows, when we go into editing mode, would then have the little green circle with the plus sign in it. And so if we just run the application again, now you can see we get the green plus. And here, tapping on it has no effect because, again, we haven't implemented any of this support yet. Now, we're going to go ahead and leave it as the default, which happens to be delete. But I wanted you to be able to see how you could influence the actual editing style for each one of those rows. And then a little bit later, you'll have the opportunity, if you desire, to go ahead and actually add in some addition support. So we'll do a lab where you'll add in support for being able to add rows as well. And so that's the entire lab exercise, adding our right bar button and then overriding the editing style for row in order to present the delete option. Let's go back to the slides and talk about how we can now commit these editing operations so that when we tap that delete button, we actually see the row get removed. Once an edit operation is performed by the user, for example, they tap the delete button, the table view will call the data source's commit editing style to actually perform the changes. You must override this method in order to perform the requesting edit. If you don't, the editing support will not function. There are two things you need to do in this override. First, you must perform the actual editing operation to your underlying data. This would be the collection or list that's populating the table view. So you need to insert the new object or delete the existing object from the collection. Next, you need to tell the table view to refresh its UI based on the changes that have been made to the data. Let's look at both of these steps in turn. The commit editing style override is on the data source, and it's past the table view, the operation being performed, and the index or position within the table view where this operation is about to occur. Your code will almost always look like something you see here. We're told to insert or delete an item, and we receive the row position, and in response we alter the data in our underlying collection that's owned by the data source. Here, we delete the given object or insert a new one by altering the underlying data collection that's being used to populate the table view. And then we need to update the table view visualization of the data. The APIs that you use for this will depend upon the operation that's being performed. There are specific APIs exposed on the table view itself to do fine-grained updates. So here you can see we're deleting a specific index with an animation and inserting a new index also with an animation, although this animation is customized to be a fade animation. Notice that these two methods do not supply the data. Instead, they are simply pointing at the index only. And in response, the table view will call getCell to retrieve the data from the underlying data source. That means that you must update the data source first so that the data is available when getCell is called. The commit editing style method is called when the user is causing the change through the built-in editing UI. But what if it's an internal change that's driven by our application logic? It turns out that this is essentially the same set of operations. You must update the underlying collection of data and then update the table view. Here you can see we're deleting a row from our data and then removing it from the table view. Again, we can supply an animation from a set of predefined choices or even turn off the animation if we just want it to immediately take effect. The difference is you must get the index path yourself. This is done through a static method from row section, as you can see here. Since this generates a native iOS object under the covers, it also implements iDisposable, and you can wrap its usage in a using statement to release the underlying object more efficiently. This is especially important if you create a large number of indexes all at once. It's not necessary to dispose indexes that are passed to you in methods, only ones that you create on your own. One cool technique I want to mention is if you're using a separate UI table view source to populate the table view. You can use an observable collection as the backing storage, wire into the collection change notifications, and then use the TableView APIs to synchronize your table view to the changes that are being made to the observable collection. This allows you to create somewhat of a generic table source that can supply data to a table view that's automatically tracking collection changes and making the appropriate updates to the table view data itself. If it's not an insert or a delete of a row, but is instead an update of the data populating the row, then you can use the reload rows method. This will refresh the table view cell if the row is visible. Again, you can see we're creating an NS index path and then calling reload rows, passing an array of the index paths. If you include more than one index path, then each one will be refreshed in turn. Finally, if you have a lot of changes, it can be more efficient to simply reload the entire visible set of data. This is called by calling reload data on the table view. This will cause it to call getCell for each visible row that's in the table view, and the table view will be refreshed. Often, you'd like to be able to add new data into the table as well as remove it. As you saw earlier, you can return an insert cell editing style, and it will add a green plus to the row to indicate an insertion point. This is a bit trickier to implement, however, because we really don't want this on existing rows of data. Instead, we need to create a fake row that's only present when you're in editing mode. Applications will often place this row at the top or bottom of the data. Bottom is easier to implement, but top makes it more discoverable. In the app here, you can see that we've got our row at the top. So when we enter into editing mode, we insert a new row into the data to represent our insertion row. This might be added to the actual data array, or you might just track the status of the data and return a special UI table view cell from getCell when you see the proper row index. Either way, as you can imagine, it complicates the logic. Because of that, a lot of applications choose not to use the built-in UI and instead supply a button in the navigation bar to add new items. Here you can see one on the left. This is more discoverable because it's always present in the UI and much easier to implement because we don't have to juggle any special state in our app. Now that you've seen how to commit editing operations, let's go back to our application and finish off the editing support. So this next exercise is going to commit those editing operations and allow us to then delete the rows. And again, if you tap on the exercise link for exercise 2, you'll see that our primary challenge here is to implement the commit editing style method This is the method that's called when we actually interact with the table view and either tell it to insert a row or delete a row. You'll then perform the appropriate operations on the underlying collection and then tell the table view to then refresh its data using one of the methods that we discussed in the lecture. And then we'll add an add button into the UI. So we'll put this into the left-hand side of the navigation bar, and when we tap that add button, we'll want to add a new expense into the expense list. Go ahead and activate the detail screen through the show detail segue, fill in the details, and if the user saves the expense, then go ahead and commit it and show it in the table view itself. So use these high-level steps in order to work on the lab, and then fill in the details with the step-by-step instructions presented below. At the very end of this lab exercise, there's an optional section here for adding the insert feature directly in the table view itself. And so remember, we can actually tell a certain row to have an insert row, where if I tap on it, I then get a commit editing style to insert the row. We're not going to use that in the main part of the lab. Instead, we're going to use an insert button in the navigation bar. But if you're interested in trying that out, here are some step-by-step instructions for being able to do that by manipulating the state of our application and tracking when we're in this insertion state, adding a temporary fake row to the top of the table view so that I can then add my insert button. And so if you have time, go ahead and go through this part of the exercise as well. In either case, go ahead and complete the main lab exercise, pause the video here, and then when we come back, we'll go through the exercise together. So here we are inside of our expense application, and our goal here is to go ahead and implement that commit editing style method. We're going to do that in the expense list view controller. This is, again, the one that's presenting the list of expenses and the one that we edited earlier where we added the editing style for row. And so our goal here is to go ahead and override the commit editing style method. Now this method is called whenever we do some sort of editing operation on a row. So you tap the delete button, you tap the insert button, and our goal here is to detect the specific type of editing operation that's been performed, that's being passed to us here in this editing style, detect the row that it's being performed on, that's the past index path, and then do the operation to our underlying data source as well as refreshing the table view itself. And so we'll start by looking to say, what is the editing style itself? And so the editing style that gets passed is, if that editing style is UI TableView cell editing style delete, so you can see that in our IntelliSense, then we want to go ahead and first grab the actual expense from our underlying expenses collection. So we'll say the expense is expenses index path.row. We'll take that expense and go ahead and remove it from our expenses array. So we'll say remove at index path.row. Then we can go ahead and delete the row from the table view. So we'll say table view delete rows. Scoot up just a little bit so we can kind of see what's going on here. And delete rows, if you look at it, takes an array of index paths. And so we'll just create a new array and pass in the index path that's being deleted. And then we can tell it what sort of animation we'd like to supply with this. We'll just use the default one. So table view row animation dot automatic. Then finally, once we have deleted it from the table view itself and we removed it from our expenses, we want to actually save it to the local database as well. And you got the little line of code to do that. We need the expense from the actual expenses array, and what we'll do here is we'll just say await new data store dot delete and pass in that expense. Now that means, of course, that we need to put an await on, or an async rather, on this method, so that we have the async to decorate the method, and then we do our await here on the data store delete, since that's an asynchronous method. Now this should allow us to then delete our data. So this should be all we need to do in order to actually run the deletion of the data itself. Let's just put a breakpoint here, and we'll run the application in the simulator. Let's go ahead and go into edit mode, and let's delete our taxi to dinner. So I'm going to click on the minus, I'm going to click delete, and notice we end up here inside our commit editing style. If we kind of track through this, you can see that the expense is our taxi to dinner. So there it is, taxi to dinner. We're going to remove it from the array. We're then going to tell the TableView itself to delete the rows, and then we're going to go ahead and delete it from the actual local database. When we do that and we switch back, you can see that it's no longer here. If I close the application and come back into it, that expense should still be missing. Since we saved it to the database, we should no longer see that expense inside of our list of expenses. Now, the next step that we're going to do is try the built-in delete gesture. And so it turns out that once you implement this commit editing style, you actually have another way of issuing delete, which is to slide the row from the right to the left, which reveals the delete button. Now, this is going to initiate the exact same action as going into edit mode. So notice we have a done up here to take us out of edit mode, even though the only row that's actually in edit mode from the TableViews perspective is this final row that we did the swipe gesture on. And so when we click delete, it's going to go back through the exact same actions that the other approach used, where we actually click the delete circle and then click the delete button. We went ahead and removed it from our collection. We went ahead and removed it from the table view, so updated that row in the table view and then saved out the change to the database. So those two operations are going to be exactly the same in terms of their implementation because they're both coming through that commit editing style. Now, the last thing that we want to do here is add in some support for adding a new expense. Now, to do that, we've actually got to do a couple of things. So first, we need a button in our UI that's actually going to drive this. And so let's go ahead and add a new button into the UI for adding an expense. And so we'll just go ahead and come up here where our right bar button item was being added. Let's create a new add button. That's just a new UI bar button item. And we can use a bar button item system item.add, so we'll just use the normal plus sign for that. And what we pass to this is actually just an event handler. So I'm going to call this on add expense. And we'll come back to that in a second. And then let's add this into our navigation. So we'll say navigation item, left bar button item will be our add button. Now, this is just an event handler, so it takes an object, sender, and an event args. And if we're lucky, you can hold the Alt key and hit enter and get a pop-up here to actually create that, but notice it's not actually doing that for us. So I get create field, create property, create local variable, and put inside using, none of which are the appropriate actions that I want. So we'll just have to type it in. But Visual Studio users might be able to get that refactoring support to be able to add a method directly. So we'll just say on add expense, object sender event args e. And so this will be our add expense method. Now, what do we need to do in our add expense method? Well, the first thing we need to do is actually create a new expense. So what we want to do is take us to the details screen where you can fill in that new expense. To do that, we have to have an expense to work on. So I'm just going to create a new expense object here. We'll leave it as null by default, and then we'll just create it when you tap on this. So we'll say create a new expense, and then what I want to do is go ahead and navigate to that other screen. And so the way that we can do that, since this is just a segue that's been created in the storyboard, if you look at the storyboard for this application, you'll see that there's a segue going from the table view into that details view. So when this finally comes up here, we'll be able to see that. So here it is. So notice we go to this from the table view itself to a details view that comes in. It's this segue right here. And so notice the identifier is show detail. This is the important thing. We need this identifier in order to actually activate the segue in code. The way that we do that is we just call perform segue and we pass in the name of that identifier, show detail. We can then pass in the sender, which will be this. It's the thing actually initiating the segue itself. And this will then go through the same logic as if we tapped on an item. And so it'll pass us the specific, it'll essentially run the same segue as if we tapped on the item, which is the wire up that's done on the segue in the storyboard itself. And so we're going to end up going through this same code down here, prepare for segue. But we're going to have to massage this code just a little bit because right now it assumes that the expense that we pass in is the selected expense. And when we activate it through this perform segue, we won't have a selected expense. Instead, what we want to use is the new expense. And so if there is a new expense, then we want to go ahead and use that instead. So here inside of prepare for segue, let's do this. Let's say selected expense is equal to new expense, all right? Or if new expense is equal to null, then let's go ahead and use the expenses table view selected item. So some of you may not be familiar with this operator here. This is a null coalescing operator. It basically says use this value if it's non-null and this value if this one is null. All right, so we're either going to get the new expense or we're going to get the index or the item out of our expenses collection from the selected row. And then that will be passed in as the selected expense. Now, the last thing that we need to do is when we come back to this screen, presumably you've then filled in the details for that expense and then you hit the save button and you went back, or you hit the save button and it takes you back. We want to go ahead and catch that, and if the new expense, this right here, is non-null and it has an ID, meaning it's been saved to the database, we want to go ahead and make sure to display it in our table view. To do that, we're going to override one more method, which is view will appear. So this is called when we're either navigating to this screen initially or when we're navigating back from the detail screen. And so what we're going to do here is we're going to say if the new expense is not equal to null, then we want to do some stuff. And at the very end, we want to go ahead and make sure to reset the new expense to null. So that will close off this state. So when we first tap the add button in the navigation bar, we'll create the new expense, we'll navigate to the details screen using that new expense here. When we come back, we'll go ahead and clear the new expense so we're no longer in that state. But then we can test the new expense ID, and if it's not 0, then that means that it got saved to our local database. So ID gets filled out by SQLite when it gets inserted into the table. Then what we can do is we can say expenses add. So remember, this is our collection. We'll add that expense in. And then what we want to do is just reload our data. Now we could do an insert rows here, but since we're coming back into this screen, it's going to reload anyway. So we'll just say reload data and let it just reload everything. So there's nothing wrong with this because we're coming in and the view hasn't been displayed yet anyway. So we'll just tell the TableView, go ahead and make sure to query each one coming in. Now when we run this, oops, we need to make sure to use new expense there. When we run this, what we should now see is a new add button in our navigation bar. So now we have this little plus on the left-hand side. I tap this, it takes me to my expense detail where I can say taxi to dinner. Let's say that was $100, it was an expensive one. We're going to go ahead and let it be billable, and let's set our category to transportation. And then let's go ahead and save it. And then notice that we get our taxi to dinner. It's blue because it's billable, and it's $100. I can still delete this. If I were swipe to the left, I can hit delete, and then notice it goes away. So now my plus is working to add a new expense. And if I come in here and I don't bother to save, I just go back, we don't get another expense in here. All right, so it's only if it gets saved to the local database will we see that expense. Now, there was an optional part to this lab, which was to actually use the insert feature that's built into the TableView. So the idea is to provide a fake row at the top of the TableView that actually uses the insert cell editing style. Now, this is a bit more complicated because it requires us to track some additional state to this. So the first thing that we're going to do is we're going to have to track whether or not we're in this special insertion mode or not. In other words, if we've put a insert row at the top of the table view. We'll do that with a Boolean that we'll just call has insertion row. We'll set it to false initially. And what we'll do is when the system is requesting the editing style, if we are in this special insert mode, then what we want to do is we want to return the insert editing style specifically for row 0, for the very first row, or for whatever row we're going to designate as our special insertion row. And so we'll say if has insertion row is true, then what we want to do is we want to say if index path dot row is equal to 0, then return UI table view cell style insert. Otherwise, we'll just return delete. And so if those two things are true, then we want to go ahead and return insert in order to indicate that that is a special row that we can use for inserting new pieces of data. Then what we want to do is we want to go ahead and override the set editing method. So remember, the set editing method is called whenever we go into or out of editing mode. So when you tap that edit button, it's going to call the set editing override. And so we'll go ahead and catch this set editing. And what we want to do here is actually we want to go ahead and call the base class, because that's what will actually activate or deactivate editing mode. But we want to go ahead and detect and either insert or remove our special row based upon whether or not we're coming into edit mode or not. And so the first thing that we need is that index path. And so we can say var index path is equal to ns index path from row section. So we want to create a new index path, and we're going to go ahead and say 0, 0. And we can actually wrap this in a using statement. So remember, this actually creates a disposable object because it's an iOS thing that we can get rid of. And then we can say if we are editing, so if we're transitioning into edit mode, then has insertion row is going to be true. So we're going to go ahead and add a new row into the table view. So we'll say insert rows, new. We'll go ahead and pass in our index path. And let's go ahead and say TableView row animation automatic. And so we'll just go ahead and insert that new row. Now, if we're not in editing mode, in other words, if we're going out of editing mode and this flag is true, then that means we've inserted the fake row at the top, because this is going to insert a new row at the top. We want to go ahead and get rid of that row. And so we're going to go ahead and say if has insertion row is true, then let's go ahead and say has insertion row is false, and let's say table view delete rows, new index path UI table view row animation automatic. So again, we'll go ahead and just get rid of that row. And so this will either add a new row at the top or remove a row from the top based upon whether or not we're going into or exiting out of the editing mode. So then the next thing that we need to do is we need to adjust our methods that populate data to account for this new row. And so let's just copy this has insertion row. Let's come down here to our rows and section, and let's say if has insertion row is true, then we want to return expenses.count plus 1. We have actually one more row in our data set when we have the insertion row. And then in our get cell, what we can do is then, if that insertion row is present, so we can go ahead and call DQ reusable cell, but we don't need to get the expense if this happens to be the first row and we have an insertion row. So we'll say if we have an insertion row, then let's go ahead and get our row. We'll say row is equal to index path dot row. If row is equal to 0, then let's go ahead and just set our cell up. We'll say the text label dot text is going to be add an expense. Let's go ahead and say the detail text label text is blank, because we want to just clear that out if there was one there before. Let's go ahead and set the text label color to something like gray, and then let's return the cell. Okay. Otherwise, we're going to go through this code here. Now, we don't want to use index path row here. Instead, what we want to do is we want to go ahead and add or take one away from the row. So if we have an insertion row and the row is not 0, then our data in expenses is actually one off from the row being presented. And so I want to go ahead and say subtract 1 from this. So if it's currently 1, that's actually the first item in our array. And so what we want to pass into here is actually 0. And so we'll use that in order to account for that. The rest of the code is perfectly fine. So we'll go ahead and grab our expense, set our text label, detail text label, go ahead and set our text color up, and then return the cell. So it's just this little bit of code here that we're actually concerned with in terms of being able to insert the data. Now, the next thing that we need to do is we need to update our commit editing style, because now what's going to happen when we insert the row is the system's actually going to come through here in order to actually do the insert. And so we have another condition here of saying if editing style is equal to UI table view cell style insert, then we want to go ahead and go through some code to insert. Now, we should always be on row 0. So the index path at this point should always be 0. Just to verify that, let's just put a debug assert in here, and let's just say index path row is equal to 0, right? Because this code here should only be entered if we tapped on that first row to insert whatever our data is. And we can just call our onAddExpense that we were using earlier. And so we'll just pass in this and event args.empty. Let it go through the exact same code that we use for the button that's in the navigation bar. And that will then create a new expense, set the new expense property up, go ahead and do the segue to get us to the details screen, and then when we come back, we'll clear the new expense. So all that code we already know works. It's just a matter of actually invoking it from here. So that should be actually all we need to do in order to take this into account. But it turns out we have one more step that very likely we're going to need to take care of. And so let me just run it just to show you how it works right now. And then I'll show you what potentially is our problem. So what we should get now is we still have our plus here. We still have our ability to swipe to delete. But when I go into edit mode, now I've actually got a new row at the top, which is add an expense. This is our fake row that was added as a result of me moving into edit mode. And when I click done to move out of edit mode, we delete that row to get rid of it. So you can see that it either shows up or it doesn't based upon whether or not we're in edit mode. When I click plus, it should go through the same logic we did before. So we should be able to say something like breakfast. Say that was $35 or $34 rather. We'll make it billable, and let's make it a meal and say done, save it, and we come back and now we have breakfast down here at the bottom. So this is all working. Now, here's where we might have a problem. When I move to swipe to delete, notice that I get my delete, but I also get my add an expense. And that's because when we swipe to delete, it's moving into edit mode, and so therefore we added this row in our set editing. However, we really don't want this row when we're just in this swipe to delete mode. So it's sort of a pseudo mode from an editing perspective. And so ideally what we would do here is we would detect that we were actually in a swipe to delete mode, and then inside of our set editing here, we wouldn't actually go through the logic to insert that row. Unfortunately, in the set editing, there's no flag to tell us that we're in a swipe to delete sort of mode. So what we have to do is we have to detect that a little bit later in the process. And the way that we're going to do that is we're going to override the will begin editing operation. So will begin editing is called as part of the whole editing process, and it's actually called after set editing. And so what we can do here is we can say if we have an insertion row, then let's set that to false, and let's go ahead and delete our row. And so I'm just going to copy this code here and paste it in and get rid of all of that and just leave in the table view delete rows. And so we want to go ahead and create a new index path, and I'm just going to reuse the variable that's already been passed into us, and so we'll just get rid of the var there. So we're going to create a new one at 0, 0. Let's delete that row as part of this, and let's set our flag to false so that when we get out of editing mode, when we actually tap the delete button or we click the done button, we'll come through this code here, but has insert row will be false in that case. And so this will just catch that odd case of moving into edit mode through a swipe gesture. So we run it one last time here, and now what should happen is when I go into edit mode, you can see I get my add an expense, but when I swipe to delete, we don't see the add an expense. Okay, so that handles that odd case of being sort of in edit mode but not completely in edit mode. So let's go back to the slides and let's talk about some other things that we can add into the table view. Now that you've seen the steps and the overrides that are involved, let's back up and see the whole picture together. First, the user presses the edit button to place the table view into edit mode. In response, the parent view controller will call set editing on the table view. And of course, the table view will begin to call set editing on the table view cells. Before it does that, the table view needs to determine which cells can be edited, and it does this by invoking canEditRow for each visible row. Next, it will determine what kinds of changes can be done by calling the delegate's editing style for row method, if it's implemented. The table view then updates the UI, and we're waiting for user interaction. If we end editing mode, then we'll reverse the UI and call setEditing again, this time with a false value. But let's say that the user deletes a row. The table view will ask the data source to commit the change, and in response, the data source will update its data and call delete rows on the table view to remove the cells. The table view will then refresh the UI using the getCell method to retrieve any new cells at the end which are now visible. When you use the swipe gesture to delete a row, the table view places that single row into edit mode. This is slightly different than the full editing experience in that the edit bubbles are not added to the UI and other rows are not redrawn. If you need to distinguish this workflow from the normal editing experience that's activated through an edit button, you can hook into two additional methods exposed on the TableView delegate: will begin editing and did end editing. These methods bookend the editing process for a row and indicate when the edit operation starts and when it ends. If you need to distinguish between single row edit mode versus a full edit experience in the TableView cell, you can override the will transition to state method in the UI TableView cell itself and check the past mask parameter for the showing delete confirmation mask value. This is passed to indicate that the system provided delete button is being rendered. In addition to what you see here, if the edit operation is canceled, you will see a few additional method calls to reset the cell visuals and turn off the edit mode on the UI TableView cell. Here we're showing that the cell is being deleted, and so these calls do not occur in this case. The last interesting built-in editing feature is the ability to reorder rows in the TableView. You've not seen it in your app yet because this feature is turned on independently from the insert and delete editing operations. It turns out this isn't as common as insert and delete, but for some types of data, it might be a valuable feature to activate. To support it, you have to override the canMoveRows method on your TableView delegate. This method is also called on a row-by-row basis and must return true if the row is movable. The default is to return false, which is why you've not seen this feature. Also, the row itself must be editable. That means the canEditRow method must also return true for the row to enable this feature. If both of these methods agree, then a row movement adorner is added to the end of the row, as you can see here. This can then be touched and dragged to reposition the row. When the drag operation is complete, the delegate's moveRow method will be called to indicate the original and the final position of the row. In this case, the table view will have already moved the visual cell. There's no need to refresh the table view. This function only needs to reorder the underlying data itself. Because the UI is updated automatically, the table view will not allow row movement unless you override this method. So the UI will not be shown if this method is not overridden. Finally, you can provide some rules about row movement through the Customize Move Target method. This allows you to preview a change and decide whether to allow it or to return a new position for the row. Your logic will then dictate how rows are reordered using the built-in UI. So let's do a flash quiz just to cap off our knowledge. Question number 1. To turn on interactive editing, you can A. Set UI TableView editing equal true, B. Override canEditRow, C. Call UI View Controller set editing, or D. Override enter edit mode. The answers are A. Set UI TableView editing equal true, and C. Call UI View Controller set editing. Question number 2. You must edit the underlying data source and the table view when committing an editing operation. True or false? And the answer is true. You must edit the underlying data source and the table view when you commit the editing operation. Question number 3. To support interactive row movement, you should override the blank and blank methods. A. canEditRow and commit editing style. B. canMoveRow and moveRow methods. C. canMoveRow and customize move target methods. And the answer is B. canMoveRow and moveRow. So now you've seen the basics of turning on the editing mode experience within a table view. The important thing to remember is that the UI itself is provided completely by Apple, meaning when you use this particular approach to provide editing features to your table view, then you're always going to be following the human user interface guidelines that have been documented by Apple. As you've seen, it's very easy to turn on and provide the methods that will actually do the data manipulation. So let's look at some more common things that we can do with a table view. Specifically, let's look at some features that have been added into more recent versions of iOS. We've got two things that we're going to examine. First, in iOS 8, Apple added support for row actions to be made available when you left swipe on a row. This is an extension of the delete button that you saw earlier and allows you to create custom buttons which are revealed during the swipe gesture. Second, iOS 6 added official support for the pull to refresh gesture when using a UI table view controller. So let's take a look at both of these features in detail. Editing actions are revealed on a table view row when you swipe from right to left on the row. This swipe gesture has become a very popular way to expose common activities for a table view. It was popularized by several third-party applications and even used in Apple's own Mail application before it became an official documented API. You can add a set of buttons to each row. The number of buttons depends on the screen size. If there are too many to be displayed, then the system creates a More menu, which shows the additional actions in an action sheet pop-up. Adding this support is quite easy. We just need to override a single method on the TableView delegate. The method in question is edit actions for row, which is exposed on the TableView delegate. This is called when the left swipe gesture is performed on a row, and it should return an array of UI TableView row action elements. If it returns null, which is the default, then no actions are shown, or if the row can be deleted, then the delete button is shown. That assumes, of course, that the row can be edited and has a delete action, and that you've overridden the commit editing style method. If you return an empty array, then no actions are shown and even the delete button is going to be suppressed. If you return at least one action, then it will display that as a button on the row. You create these row actions using the factory method UI TableView row action.create, as you can see here. And it has several parameters. First, each created row action has a style: normal, which is displayed by default as a gray button, or destructive, which is shown in red. It also has a title and a .NET delegate handler, which is called when the action is invoked. You can also adjust some of the visual properties of the action. For example, the background color of the button can be set to any color. Here, we're setting it to blue. Remember that this method is called each time you swipe on a row, and it gets past the TableView owner and an index path of the row that's being interacted with. You can create an array of actions and return a unique set each time. This would be useful if the actions are highly dynamic or tend to change on a row-by-row basis. However, that's not terribly common in the real world. More often, the actions are identical for each row. Here's an example where we create a class-level field to hold our actions and then create them the first time that the user activates the row action, allowing us to cache them off and improve our performance by only having one set of row actions. The .NET delegate method associated to the action receives the action itself as well as the index path that the action was invoked on. This callback would then perform whatever work needs to be done and refresh the TableView's representation of the row if it's been changed. That means that you're going to need access to the TableView itself because it's not passed to the method. Here we're assuming that we're in the TableView controller, which always has direct access to the TableView through a property. The custom editing action workflow looks a lot like the system-provided swipe to delete gesture that we saw earlier. The order of the events is slightly different. Will begin editing is called much earlier in the process, and more importantly, the TableView delegate does not get a call to turn on editing mode. Notice that there's no call to set editing like we saw in all of the other editing scenarios. So if you're relying on the set editing method to know when you're transitioning into edit mode, be aware that in this specific case, the TableView will not call that override and you will need to use the will begin editing instead. So let's go back to our application and add support for some editing actions. Here we are in exercise 3, and our goal is to add some new swipe gesture edit actions into our table view. And so you're going to continue from the prior exercise where we added in support to be able to both delete and insert new rows. And if you added in the actual insertion row at the top, that's fine. I actually am using the completed solution from part 2, which is just the add button. And so I don't have all that extra code in there just because it complicates things and makes it a little harder to see what's happening inside the application. But you can continue on from the point that you've left off. Our goal is to override the edit actions for row method, which is going to allow us to add new buttons when we swipe to the left. And so by default we get a delete button, but we're going to replace that with our own set of actions. And your goal is to replace it with 2 buttons, one being a delete button that you're going to implement yourself, and then the second one will be a billable or not billable flag. And so you'll either get a billable button, which will be in blue, or a not billable button, which will be in gray, depending on the state of the expense. And so if the expense is billable, then you should see a not billable button. If the expense is not billable, then you should see a billable button. And so you'll want to make it a little more dynamic. You'll also have to implement the logic to do both of those operations. And so you'll have 2 methods that are tied to these actions. The first method will delete the row, and so you'll have to delete the item out of the expense collection and then call delete rows. And then go ahead and save that to the database. And then the second option, or the second method, will flip the billable flag and force the row to refresh. So you will want to reload the row that you've affected so that you get it to switch from the gray text to the blue text and vice versa based upon whether or not it's billable or not. So use these high-level steps and then use the step-by-step instructions below to fill in the details, and when you come back we'll go through the exercise together. So here we are inside of our expense application, and as before we're going to go ahead and edit the expense list view controller file. And our goal here is to implement the edit actions for row method. So this is a new method that was added into iOS 7 in order to supply those edit action buttons. And so to make this as optimal as possible, what I'm going to do is I'm going to cache them off. And so I'm going to go ahead and just create a TableView row action array called edit actions. And then we'll go ahead and create that the very first time inside of our edit actions for row method. And so when we override edit actions for row, I'm going to say if edit actions is equal to null, then let's go ahead and create them. And then at the very end, we'll return the edit action. Let's go ahead and create them. And so we'll say edit actions is equal to new array. And let's put in some default edit actions. Now remember from the lecture you saw that the way we created edit actions is through a factory method, which is on the TableView row action, and it's called create. We pass in the style for it, so this would be the UI TableView row action style. And so for this very first one, let's go ahead and say it's normal. And let me move these down so that we can kind of see them a little bit better. So we'll say the first one is normal, and I want to go ahead and pass in the text billable, and I'm going to create a new method called onFlipBillable. And so this is just an action method, and we'll get past a couple of parameters to indicate what is the row action being performed and what's the index that it's on, what item are we doing it on. And so this will be my very first one that we're creating. Let's go ahead and just copy that, and let's create a second one. And instead of normal, let's actually make this row action. This needs to be style. That's why it's in yellow there. There we go. Let's make this second one, instead of normal, let's make it, actually normal's fine for that one too. And what we're going to say is not billable on this, and we'll pass it to the exact same method, onFlipBillable. And then finally, let's put one more on here. And for this one, we're going to use destructive. So destructive shows up as a red button and kind of just indicates that you're going to delete or modify this in some way that the user might not be prepared for. So it's kind of a warning sign. And let's just set the text to be on delete. Set our text to be delete rather, and set our method to be on delete. Okay, now I need to implement all three of these, and I probably would want to go ahead and localize this text as well, and so I'd want to use some sort of localization mechanism, probably the built-in one in iOS in this case. For this lab here, just for simplicity, I'm just going to type in some default strings here. Now, we've got our edit actions, and so let's go ahead and do a couple of things. And so I've created my array. Let's go ahead and set the first button's background color to be UI color blue. And so that first button, the billable button, will make it blue instead of gray. The default is gray. And then finally, I mentioned when we started this exercise that we want to filter this so that we only want to show billable if the expense is not billable, and we want to show not billable if the expense is currently billable. And so really I only want 2 row actions. I don't want 3. My billable and not billable are mutually exclusive with regard to each other. So let's do this. Let's go ahead and create a new row actions array, and let's put 2 items into it. And then we can say row action 0 is going to be, is the expense billable or not? So I need to go retrieve the expense itself. And so right up here, let's just say var expense is equal to expenses index path dot row. And so we'll go grab the row from the past index path, pull it into our expenses here, and then we can say if the expense is billable, then what we want is the edit actions 1. Otherwise, we want edit actions 0. So if it's billable, then we want to show not billable. If it's not billable, we want to show billable. And so that'll give us our first item. And then we can say row action 1 is going to be equal to edit actions 2. So that'll always be our delete. So now that we have our edit action, let's just go ahead and return that, row actions, from the method. That'll give us our buttons. Now, in order to compile this, we need our on flip billable and our on delete. Now, this time, notice that my alt enter does actually work, and I can create a new method. We can just put it right here. It gets passed a row action. Let's just rename these. These aren't great names. And then this is the index path. And so in my on flip billable, what I'd like to do is I'd like to go get the expense. The expense is what was passed on the index path, and so let's just copy our line from here, paste it in, so that's the expense, and we can say expense billable is equal to not expense billable. So I'm not going to bother to check and see what the action is, although we could say is it the billable one, make it not billable, etc. We're just going to assume that this logic up here worked properly, and so all we need to do is just flip the flag in this case. Then let's go ahead and tell the table view to reload that. So we'll go to our table view property and say reload rows, passing in this index path. So that's the one that we just edited. And then we'll say row animation is automatic. And then finally, let's go ahead and save this to the database. And so I'm going to do an await new data store, update this expense. And so let's go ahead and put an async on our method in order to allow for the await. And so this will just make sure that we save it to the database. So that'll handle our on flip billable. Now for the on delete, let's come down here and let's create an on delete method. Now we could actually reuse the logic that's inside of our commit editing style. So remember, we have all this delete object or delete logic that's right here. So we could take all of this logic, I'm just going to copy it, and then come up here to on delete, and let's just paste it. And so this will be our action, and this will be the index path. And so this logic should be actually exactly the same. We'll take the index path row, go grab our expense, remove it from here. We need to use the full table view property here to delete the row, but we'll pass in the index path, and then we'll go ahead and put an async on here so that we can go ahead and delete the expense. Now, the question is, could I reuse this logic? Well, absolutely we could. So we can come down here, and instead of having all this same logic in here, let's just delete this, and let's call on delete. So we'll say on delete, pass in null for the UI table view row action, and pass in the index path that got passed to us. That'll then reuse this delete logic so that we get the same logic when we commit the editing style. So let's give this a shot and see how it works. I'm going to run it again in my simulator. My app comes up. I can then swipe my finger and notice now I get delete and billable. I click billable and notice my text changes from blue or from black to blue. Do it again, I now get not billable and it goes back to black. And if I click, of course, the delete button, then it gets deleted. Now notice the order that it's in. So it's in the opposite order of what I presented here. And so let's go up here and let's fix that. So we'll just swap these and say this is row 0, or row 1 rather, and this is row 0. Now when I run it, we should get delete at the very end, which is kind of what we want. And so now I swipe it, I get billable, not billable, here on this very first button, and then delete. And so make sure that you put them in the correct order in order to display them. They're actually done in opposite order from what you see here. So let's go back to the slides and talk about another useful gesture that we can add into the table view. The second feature we'd like to look at was popularized by Twitter on iOS, and it's the pull to refresh UI paradigm. This is where we drag the table view down to get it to refresh its contents, displaying an activity indicator running on the top while the data is being processed. Many applications built this into their table view data, but formal support was added into iOS as part of iOS 6, and it's super easy to take advantage of. The support was included in the UI table view controller. If you're not using a UI table view controller, then you'll need to do most of this on your own in code. The first step is to create a UI refresh control and assign it to the refresh control property of your UI table view controller. There are no options for this, just assigning the control will activate the feature. Next, hook the value changed event on your UI refresh control. This is called when you drag the table view downward and is the signal for you to refresh your data from whatever remote data source you're getting it from. This is called on a background thread so that the UI will continue to function properly. Next, when you're finished updating the data source, you need to tell the UI refresh control that you're done. That's accomplished by calling the end refreshing method. This must be called on the UI thread, and so here you can see we're using begin invoke on main thread, which is a Xamarin iOS mechanism to marshal back to the main thread. Once you call this, the table view will slide back in place and the activity indicator will be removed. The last step is to refresh the table view itself. The easiest way to do that is to just tell it to completely reload the data. This also must be done on the UI thread, as you can see here. So let's switch back to our application and add support for the pull to refresh gesture. So here we are in exercise 4. And our goal is to add support for the pull to refresh gesture. And you're going to do a couple of things to accomplish this. First, you're going to create a new UI refresh control and assign it to the refresh control property of the table view controller. Then you'll wire into the value change property on the UI refresh control. This is what gets signaled whenever you actually do the gesture and pull the table view down. You'll reload your data by calling a method on the data store called reset. And so here's the little bit of code that you'll need in order to reload your expenses, and this will just reset it to the default set. So any changes that you've made will be thrown away and will reload back to the original set that we started with from the application itself. Then you're going to go ahead and reload the data in the table view and call end refreshing in order to get rid of all the UI and the activity spinner, and so everything will kind of return back to normal. This is actually a very fast exercise. It shouldn't take very long. So go ahead and pause the video here and go off and do that to your code, and when you come back, we'll do the exercise together. So I'm back in our expense application, and I'm going to open up the expense list view controller. And I'm going to move up here to our viewDidLoad method. And in the viewDidLoad method, I want to go ahead and create a new refresh control. And so we'll do it right after we do the add button here. And so let's say UI refresh control is equal to new UI refresh control. Notice it doesn't take any parameters. We can just go ahead and create one. Then let's go ahead and wire up to the refresh control value changed. This will pass us a sender and event args. We're going to do some logic in there, and then as a final step, we want to go ahead and set the refresh control property on our table view to this refresh control object that we just created. So what do we need to do here? Well, the first thing you need to remember is that this is called on a background thread. So we're no longer on the UI thread when this gets invoked. That means that we can do some interesting things here. We can do background tasks and not have to worry about the UI thread being impacted by whatever our activity is. And in our case, what we really want to do is we want to go ahead and reset the data store that we're working with. And so I'm going to go ahead and take my expenses array here, and I'm going to say, let's go ahead and create a new data store. Let's call reset. And then let's take that and actually turn it into a list. So this comes back with an IEnumerable. So I'm going to go ahead and surround this and call toList. Now it turns out that this method, reset, is actually an async method, and we also need to make sure to add in our system.link to the top here as well. So let me just come up to the very top and say using system.link just so that I can use that toList option there. Now it turns out that this is an async method, and so it's actually returning a task. And so I want to go ahead and put an async on the front of my event handler so that I can come to my new data store and I can say await the new data store, so await this reset, take that IEnumerable and do my toList on it, and then that assigns back to my expenses. And so no matter how long this takes, we really don't care. It's going to do some database work, save some stuff out, maybe it goes and pulls it from a web service. We really don't care at this point. The point is once it's finished, we then need to actually refresh the table view and tell the UI to go away, the reloading UI. But we need to be on the UI thread to do that. And so we're going to use the begin invoke on main thread. This takes an action as its parameter. And so we're just going to use a little lambda here. So we'll say create the lambda and let's call TableView reload data, because we want the entire table view to refresh. And then let's use that refresh control and say end refreshing. And that will then turn off the UI and put the table view back into its normal state. And so this will then cause our UI to actually be reset back to its original state. Now, just because this happens so quickly, let's put in one more little piece here. Since this is an async method, let's do an await task delay, and let's just delay for 5 seconds, just to know that we're actually doing something in here, because this is going to happen really quickly. And so I'm going to go ahead and run this. And so now what I can do is I can pull this to refresh. It'll take 5 seconds to refresh because we're doing the task delay, but when it's finished, at the end of that 5 seconds, my UI will be refreshed. I get my original pieces of data here, and notice that the refreshing UI, the activity indicator itself, went away, and then my table view slid back up into place. So let me do it one more time. I slide it down, we get our activity indicator for 5 seconds, and then once the 5 seconds elapses, the UI goes away. And so that's the pull to refresh gesture. So let's talk about the last piece, which is adding some search capabilities into our app. So now you've seen two common things that we can also add into our table view to supplement the editing experience. Swipe gestures, which reveal different actions that we can supply on a row-by-row basis, and the pull to refresh gesture, which is really helpful if your application is pulling data from some remote source. The last thing that we want to cover isn't really an editing operation, but is instead a filtering operation on the table view. Let's talk about adding a search experience to our user interface. We've got several topics to think about. First, we're going to look at the underlying UI that's supplied by iOS to perform searches. That's in the form of the UI search bar control. Then we're going to move up a level and talk about a built-in controller which can add the search UI and derive the experience within our application view. Finally, we'll talk about a cool option of the UI search bar, which is to provide scopes or categories to the search. To start with, iOS has a built-in search bar which provides a standard system UI that you can use for searching. It is highly customizable, allowing you to change the exposed features, colors, and even behavior through properties in an associated delegate class. You can add a search bar into your application either in code or using the designer. There's a search bar component in the toolbox. In either case, you can use a variety of properties to control the UI and exposed features. The text is what the user types. There's a placeholder property which displays some gray light text to indicate what to type. Here you can see we've got it set to enter search term. There's a prompt property which gives you a longer title that's displayed just above the search text box. There's a bar tint property to adjust the background color of the bar, and there's some options that you can turn on that enable different UI elements, such as a previous results button, bookmarks, a cancel button, and the scope bar itself. You can also control the behavior of the UI search bar through a delegate class, the UI search bar delegate. By implementing this class, you can get notifications about how the user is interacting with the search bar. For example, each of the buttons in the UI will invoke a different method on the delegate. There are several common overrides that we'll supply. Should begin editing is called when the user taps in the search text box before the UI is changed. On editing started is called once the search text box is the first responder and the UI is now showing the entire search bar. On editing stopped is called when the user ends the search. Text changed is called as the user changes the UI text field associated with the search bar. And the search button clicked is called when the user taps the search on the keyboard. You can use the search bar directly if you like, but Apple's also provided a higher level controller which will handle all of the UI logic of showing and hiding the search bar automatically. It creates and controls the search bar experience and ensures that your search support works exactly the way Apple says it should. The class we're interested in is the UI Search Controller, and it was added into iOS 8. The Search UI provided can work not just with table views, but also with map views or any other custom view that you might create. It's quite flexible, and if you're providing a search over a table view, for example, it can reuse the table view to display the filtered results. If we're displaying search results for some other view, then you can get it to create a new table view to display the results and overlay the screen. Because it was introduced in iOS 8, it fully supports adaptive design, resizing and performing layout automatically based on the size of the device. And finally, it's easy to use, but still fully customizable if you want to take full control over the search experience. It utilizes a UI search bar internally, and you can access that UI and customize all the things that we've already seen. Be aware that this controller only works on iOS 8 and beyond. It will crash your application if you try to use it on older versions of iOS. If you must support iOS 7, then you can use an older deprecated UI Search Display Controller class to create a similar experience, although it's a bit more cumbersome to work with, and it's only designed for full-screen table view searching. So we're going to focus on UI Search Controller being the most modern and latest way to implement searches. Let's look at the steps necessary. The first step is to create the UI Search Controller itself. We don't have designer support at this point, so instead we're going to create an instance of the controller in code, typically in our viewDidLoad method, and save it off in a field. When creating the search controller, you can either pass a separate search results controller, this would be the table view that you'd like to actually display the results in, or if the owner is already a table view, then you can pass null to use the table view controller owner itself. If you want to display the results in a new table view, then pass the specific view controller as this parameter and the system will pull it up over the existing view and dim the background. There are multiple overrides for this constructor, so make sure that you cast your null to a UI view controller to ensure that you get the proper constructor. In this case, our application is already displaying a table view, so we can just reuse it. However, we don't want it to dim the background because there's no view overlay in this case. And so the next thing that we're going to do is set the dims background during presentation property to false. The search controller will create the UI search bar on our behalf, but we still need to add it to the UI. We're going to do this by setting the TableView header property to the search controller itself. This is a property that's exposed by the UI table view, and it will integrate the search experience right into the table view and make it a seamless part of the experience. The next line of code is a bit odd. In some situations, it's possible that the size of the UI search bar does not get set correctly, and it will have a 0 height and therefore not be displayed initially. This appears to be a bug in iOS 8. There's actually a radar report that's been issued for it. But there's an easy fix, and that is just to call size2fit on the search bar property after you've set the TableView header property to insert it into the view hierarchy. It's very likely that when you try this out, you may not even need the size2fit method itself. However, we're including it here just for posterity. Next, since the search view slides down and covers part of the table view when it's active, depending on our view layout, we might have to make the owning TableView controller define a presentation context. Let me explain this a bit further. The presentation context defines the presentation area that's usable by a view controller. By default, this is provided by the root view controller and represents the full screen. When we present the search UI, iOS will walk the parent view chain and look for a context to decide what area it can overlay and how to shift the content around. A common problem is that it will overlay the wrong area of the screen. For example, if you have a navigation controller and push a second screen into the usable area, the search bar should now be below the navigation bar. However, in some circumstances, it won't be displayed there, and the navigation bar will be overlaid by the search bar. Not a great experience, and certainly not what we want. We want to make sure this works properly, and so we define a presentation context on the view controller that's defining the frame where we want the search bar to overlay. That would be the TableView controller in this case. That all sounds very complicated, but it's actually very easy to implement. All you need to do is set the new iOS 8 defines presentation context property to true on the owning view controller. And that way, when iOS is determining what the frame should be, this will be the first presentation context it hits, and it will use the frame defined by the TableView itself, pushing that portion down but leaving the navigation bar in place. This step is not always necessary, but if you ever find the search bar overlaying the wrong part of the UI, you can simply set this property to fix it. And so again, we're going to include it because it doesn't hurt anything to have it turned on, even if it's not necessary. To get notifications from the search controller, you must set a search results updater. This is a simple interface, IUI search results updating, which has a single method that is called as you change the text in the search bar. Now remember, we could actually hook into the delegate of the search bar and use the text change method. However, this is wrapping that search bar experience and presenting it up through this interface. The most common approach is to implement this interface on the owning view controller and then pass in this as the instance for the search results updater property, as you can see here. The search bar will then call the update search results for search controller method when anything in the search bar has changed. The application can then respond by filtering the data in the results table view to match the given filter. Lastly, we need to display the search results. This can either be done with a new table view that's presented on top of the parent view, or it can be directly inserted into the existing table view by replacing the data. If you reuse an existing table view, which is fairly common, then you will need to modify the methods that supply data to that table view to use your filtered data. That typically means adding some conditional logic to the getCell and the rows and section methods. You can check the active property on the search controller to determine if a search is currently running, and then use the filtered results in your getCell and your rows and section methods in response. So let's try this out by adding in a search experience into our application. So in this final exercise, we're going to add some search support to our TableView controller by adding in a new UI search controller. That will create the search bar along with all the UI that's representative of that and allow us to then filter our current TableView display to be a filtered list based upon some criteria that we select. So our challenge is to create and add the search controller and the search bar to the UI. The steps for that were shown in the slides, and so you can go to the slides and kind of walk through those steps. We're then going to implement the IUI search results updating interface. That's what the callback is going to be whenever we type in new text into the search bar, and that's how we're going to then filter our table view results. And that filtering is going to be supplied by modifying the getCell and the rows and section method. So we're going to actually update the data that's being presented in our table view based upon the search results. So go ahead and use this challenge along with the step-by-step instructions that are presented here to work through the lab exercise, Pause the video, do that work, and when you come back, we'll walk through this together. So for this final exercise, I'm going to go into the expense list view controller, and we're going to add in some support for a search experience. And so the first thing that we need to do is we need to actually add in a new UI search controller. I'm going to make this a class level field so that we have access to it. I'm just going to call it search controller, and we're going to go ahead and create it inside of our view did load. Now in this particular case, we have to do this after our expenses have been created. So because the search bar itself can cause some different things to get called, and in particular it may end up calling rows in section or get cell at some point, and so we want to make sure that we have a list of expenses even if it's empty. And so let's go ahead and create it. Search controller is equal to new UI search controller, and notice that it has several overrides here. So we have a default constructor, we have one that takes an NS coder, one that takes a view controller, and then back to the default. So those are our three. The one that we're actually interested in is this very first one that takes a view controller. Don't use the default one. It won't work properly with a table view controller. So what we want to do is we want to go ahead and pass in a view controller, but we want to just pass in null in this particular case, because we want it to reuse the current owner for the search controller itself. So this will basically say, don't bother to try to overlay a new view on top of the existing one, use the one that is your parent. Once we've done that, we can then go ahead and start assigning some other things. And so let's go ahead and say search controller dot dims background. So we don't want it to dim, so we're going to say false for that. All right, so we don't want it to actually dim the results, and then we need some way of actually gathering those results. And so we'll say search controller, search results updater, and I'm just going to go ahead and implement the interface on our table view itself. And so the table view will be the thing that actually does the work of filtering and that sort of thing. And so notice it's giving me a little error saying, wait a second, your current class, this doesn't implement IUI search results updating. So let's just put that onto the class itself. I'm going to move this down a line and say IUI search results updating, and then let's use the built-in Alt Enter or Option Enter on the Mac to implement the interface, and we'll just place it right here. And so this will be the code to actually do that work, and that'll satisfy our this option that we've added in here. So once we've got that in place, let's add in a few other options. So one of the things we want to do is put this into the UI. Remember, the way we do that is we go to the table view and we set the table header view. We're going to go ahead and set that to the search controller, search bar. And so that'll be the actual search bar presented into the table view itself. Then what we want to do is we want to go ahead and say defines presentation context is equal to true. So we want our parent to define the presentation context. And then we'll say search controller, search bar, size to fit. Now these last two lines probably are unnecessary in this application. I'd bet if we commented these out, our application would continue to work just fine, but it's not a bad idea to always include these lines, which is why I'm doing it here. It's not going to hurt the application at all. It'll guarantee that when the search bar sizes, it'll size to the parent's view, in other words, the table view controller. So the frame that's presented from the table view controller will be the frame that actually gets used for the search bar. And then this will just ensure that the search bar itself properly sizes based upon the initial view. So the last thing that we need to do is go ahead and remove this throw not implemented exception. I don't want that. I want to go ahead and take everything out of this, and we'll come back and implement this in a second. But let's run it just to see what our search experience looks like. So that's enough code to get the search bar into the app itself. So now you can see I get my search bar up here. I still have all my data. When I tap the search bar, notice that it kind of slides up over the navigation bar. I get my cancel button and everything sort of slid up. I hit cancel and it kind of comes back and we get our plus and our edit. And so that's kind of handy because then the only editing that I get out of this is my billable and my delete. I don't have the ability to actually add a new item through this experience because it sort of covers up my navigation bar, which is actually pretty handy. But it's not going to let us actually do any searching at this point. If I type something in like flight, notice that nothing happens. And that's because we haven't implemented our search updater yet. And so let's do that. That's going to be this method here. This method passes us the search controller, and the search controller then gives us access to the search bar, which would include the text and things that we need in order to actually implement the filtering itself. So remember that the way that we're going to do the filtering is we're going to use our existing table view, which means we need to alter the getCell and the rows in section method. So let's create, first of all, a new list that's going to actually manage the filtered expenses. So I'm going to call this filtered expenses, and I'm just going to create a new list of expense. And so this will be the actual list itself. In fact, I'm not going to initialize it here just yet. Let's do that when we actually enter into our search results. So this will be our filtered expenses. Then let's just create a new method. We'll call it filter content for search text, and we'll pass in the text that we want to filter on. And our goal in this method is to take all of the expenses that we already have in our application and filter them down based upon whatever this search text is that's being passed to us. And so let's do this. Let's say if filtered expense is not equal to null, so if we actually have if we're doing some filtering, let's go ahead and clear it because we've got a new search criteria here. And then let's add into this all the items that match our criteria. And we're just going to do this through a nice little link expression. Let's take our expenses and let's say give me all the expenses where E goes to, and let's say string.is null or white space text. Okay, so either the string is null or white space, or the expense title, let's just move it to uppercase, contains the text. Okay, so either one of those conditions has to be met. And then we'll just add all of those items into our filtered expenses. So once this is complete, our filtered expenses will either have all of the expenses if the past text is empty, or it will have only the ones that match the title of the expense, that the title actually contains the text that's there. Then once we've actually created this, let's just do a table view reload data. So we'll just refresh the entire table view with this filtered expense. Now the question is how does it know to use this filtered expense? Well, what we're going to do here is we're going to go ahead and say when we're in our getCell and our rows in section, if we have filtered expenses, then let's use those. So we'll say if filtered expenses is not equal to null, then return filtered expenses count. Otherwise, return expenses count. And then inside of our getCell, let's say if filtered expenses is not equal to null, then what we want to do is get the expense from the filtered expenses. So let's move this expense up here, get rid of the assignment here, and let's say this is an expense, and we'll say expense is equal to filtered expenses index path.row, else expense is equal to expenses index path row, and everything else can remain the same. So we want to use the same visuals regardless of whether or not we're in a search mode or not in a search mode. So now we've got some code in here that affects our rendering that says, okay, pull it from our filtered expenses if we have filtered expenses. Now the question is when do we get filtered expenses? Well, that's under the purview of our update search results for search controller. So what we're going to do here is we're going to say inside our update search for search controller, if the search controller is active, then let's go ahead and create our filtered expenses. So we'll go ahead and create a new list of expenses. Otherwise, if it's not active, let's go ahead and delete it. So let's set it to null. Then let's call our filter content for search text and pass in the search controller search bar text. That'll be whatever text has actually been typed into the search bar itself. And so here in our filter content for search text, we'll test to say if it's null. If it is null, then we won't do anything except reload the data. That'll cause rows in section to be called, but it'll use our master list of data, the expenses collection, and we'll populate from expenses. If filtered expenses is non-null, it means we're currently active in a search. We clear it, we fill it with all the expenses we want to display, and again, still call reload data. In our new rows in section getCell, we use the filtered expenses instead. So let's give this a shot and see what happens. So now I click in my search bar, I start typing, and notice I get TA and I have taxi from airport, taxi to dinner. I type DI, I get dinner. If I say, for instance, T, I get all of them. If I say G, I get flight, meal, and hotel. And so you can see it is working as I type. I get my search text. When I hit cancel, we then go back to our original set and we only see, or we see the full set here. And so that's how to implement a search bar with our TableView controller. So let's go back and look at one last thing, which is how to implement categories. So now we've seen the basics of searching, but let's talk about some of the additional options that we can turn on. First, the UI search controller creates the UI search bar for you and stores it in the search bar property. You can access this property to adjust the visual appearance of the search bar, as well as wire up a delegate object to handle its notifications. This will allow you to take advantage of some of the extra features, such as the scope bar. The scope bar lets you further filter down your search choices by category. It's activated by setting the scope button titles on the search bar to a string array. When the search experience is activated by tapping the search field, the scope bar will be expanded and displayed. And when you cancel or dismiss the search bar, the scope bar is by default hidden from view. If you prefer to have the scope bar always present in the UI, then you can set the Shows Scope Bar property. This isn't a common desire, but it shows you how extensible the search experience is. When you change the scope bar selection, the search bar delegate gets notified through the Selected Scope Button Index Did Change protocol method. This is really the only method that you need to monitor when you're using the new UI search controller. Changes in the text field are always reported through the search controller's Update Search Results for Search Controller that we looked at earlier. So we have two choices in getting this notification. You can create a separate class that inherits from UI search bar delegate, override the Selected Scope Button Index Change method, and then forward that call to your view controller in order to do the filtering. That's the approach you see here on the slide, and it's easy to do and fairly easy to understand. However, there's another approach that's a little trickier but requires less code. Since we only care about this one method, we can use a nifty trick of Xamarin iOS, an exported protocol method. It turns out that the UI search bar delegate is actually a protocol, much like the other Apple delegates that we've used in the past. A protocol is a bit like an interface in C#, but the methods expressed are optional. So unlike C#, we don't have to implement all of the methods defined in the protocol. You can assign the weak delegate property of the UI search bar to any class as long as it's an object. That class should then implement some of the protocol methods. When iOS goes to notify the delegate about something that's happening in the search bar, it will look on the weak delegate class and try to find a method that matches the protocol definition. And if it finds one, it calls it. And if it doesn't, then it just simply ignores the notification. When you implement these specific protocol methods on the class instance, you need to decorate them with the export attribute so that iOS can see them. So you can see here we've created a scope button changed method that takes a search bar and a selected scope integer. The important thing is that it's decorated with this export method. The export method has to match the signature of the Objective-C definition in the Apple SDK. So you can look these methods up in Apple's documentation to get the correct signature. In addition, the parameters passed to the method that you define need to match. And so if you look at Apple's definition, this particular method, search bar selected scope button index did change, takes the search bar and it takes an ns integer, which is the selected scope. We're mapping that to a UI search bar and to a regular .NET integer, and the binding system will automatically take care of that mapping for you. And so when iOS goes to invoke this method, the system will see your export and it will call your method, and you'll get the parameters just as you expect them. The method implementation should be marked virtual, and the parameters should be compatible with the Objective-C method signature. However, notice that the method name itself does not need to match the Objective-C name. Although, for clarity, it probably should be close just so it's not confusing. This approach is more advanced than using a derived class, and it isn't something that you'll use all the time, but for things like this where we only need one of these methods, it could be quite handy to know about this. If you're uncomfortable with this approach, then just use the separate delegate class that we looked at earlier. Finally, we need to check the scope when we're filtering out text from the search box as well. To do this, we need to retrieve the currently selected scope when the update search results for search controller on our IUI search results updating interface method is called. You can get the selected index from the search bar and then again index into the scope titles to get the proper filter. Or you can use the index with some internal array if you're tracking it that way. So let's just test our knowledge really quickly with a flash quiz. Question number 1. To add search capabilities to a table view for an application that supports iOS 8 and beyond, you should use the A. UI Search Controller, B. UI Search View Controller, C. UI Search Display Controller, or D. UI Search Table View Controller. And the answer is, of course, UI Search Controller. This is the one that we looked at. Question number 2. You can use the UI search bar control without a search controller. True or false? The answer is true. The UI search bar control itself is completely usable without a search controller. You can set properties and wire up a delegate and use it in your own UI without the search controller mechanism. Question number 3. To support searching capabilities with UI Search Controller, you must implement which interface? A. IUI Search Results Updating, B. IUI Search Bar Delegate, or C. IUI Search Display Delegate. And the answer is A. We implement the IUI Search Results Updating interface. So we've looked at several things here in adding a search experience. We first looked at the IUI search bar control itself and some of the properties that you can use to customize it. We then looked at the UI search controller, which moves us up a level and allows us to integrate the search experience into a table view or into our application. And then finally, we looked at how we can control search scopes and provide categories for our search experience. Now, we didn't actually do an exercise for that, and so there's a homework exercise that you can work on after the class is over, which will implement the scope bar into your search experience. There are step-by-step instructions that are presented in the materials that you have that you can follow along to actually add this in, and of course there's a completed solution if you just like to look at the final product. So this has been iOS 215, Editing Table Views. Again, my name is Mark Smith. If you have any questions, feel free to email me. My email address is mark.smith@xamarin.com, or you can post your questions onto the forum where we have all of our instructors. I hope you've enjoyed this video. Thank you very much for your Xamarin University subscription.